Okay, good morning everyone. Okay, so today we are going to look at this question, selected questions, all the way until equilibrium, so from the first chapter until equilibrium for AS, so this is your mid-year paper, previous past year mid-year paper. So let's actually try these questions, So if you look at the first question over here, this first question, they say that the compound contains nitric ion, oxidation state is 5, So if you want to calculate using this information, please do calculate, but there are different ways of how you can get this, because if you want to calculate straight away, if you know nitrate is -1, Mn is always going to be +2. But if let's say you are not sure, you want to calculate, you calculate. Mn is going to be X, so nitrate is going to be given N nitrogen is 5, so 5 times 2, and then oxygen 3, times -2, oxygen is -2, and there is another 2, so times 2 equals to, overall is 0, so X plus 10, minus 12 equals to 0. In the end, you still get the same, X equals to +2. It means the oxidation number of Mn is going to be +2. So if that is +2, we need to find the electronic configuration of manganese ion, Mn2+, So in this case, you might definitely need a periodic table. So the periodic table is given over here. So if you look at Mn, Mn is here, the shorthand rule, you can use argon, argon, this is 2s, 3s, 4s, 4s, 2, 3d, 1, 2, 3, 4, 5, this is for Mn. Now once you have Mn, you want to actually find for Mn2+. So how do you get Mn2+? You remove the 2 electrons, and you remove the 2 electrons from 4s, not 3d, so you are going to get Ar 4s0 and then 3d5. So that is going to be the answer that we are looking for actually, So we come back again to the question, so we are looking for 4s0, 3d5. So this is going to be the answer, So the first answer is going to be C. Let's actually move on, So the second question, you have a saucepan, total surface area is given, and it is evenly coated with copper, So the mass is increasing by this amount of mass. So we know that this is the mass of copper, So what we can do, is we can find out the number of moles of copper first, Number of moles of copper is going to be 0.186 divided by copper. Copper, you just look at the periodic table again, is 63 let's see, copper 63.5, So we just use that value, you divide by 63.5, find out the number of moles, and let's actually find out the number of moles together. You can calculate on your own. I will calculate my own over here. So 0.186 divided by 0.186, divided by 63.5, and I will get 0.0002929. I just put it like this, and this is the number of moles, and I know that for every 1 mole, for every 1 mole, I am going to have, 1 mole has 6.022 times 10 to the power of 22, 10 to the power of 23, so you can check all these values here, it's given, so 10 to the power of 23, 23 atoms, so you are going to look for this number of moles. So what we need to do is, you just need to times 0.002929 times 6.022 times 10 to the power 23, find out how many atoms of copper that we have over there. So once you find out, you can calculate also. Help me to calculate. okay, but I will try to calculate on my own also. Okay, so here I have 0.002929 times 6.022, and I will have 0.018. Okay, 0.018 times 10 to the power 23. What I can do, okay, I can bring this, okay, 1.8 times 10. Okay, I moved 2 places, so 1021. Okay, this is going to be number of atoms, okay, of copper. So they say per cm cube. Okay, so 140 cm cube. So if you want per cm cube, you divide, okay, 1.8 times 10 to the power 21, you divide by 140 to get for 1 cm cube. Okay, 1 cm cube, 1 cm square, yeah, 1 cm square. So I will divide, okay, so I just put 1.8, okay, divide by 140. I will get, okay, which is going to be 0.013 times 10 to the power 21. So if I bring this over here, so I'll get 1.3 times, it's a smaller number, okay, 10 to the power of 23. Okay, sorry, I need to minus. Okay, so 10 to the power of, okay, 2, so it's going to be 19 minus 2, yeah, so 1.3 times 10 to the power of 19. So I will get the answer as B. Okay, hope you still with me. Now the next question is going to be in a research, okay, on the atomic nucleus. Scientists has been comparing the stability, and then they say it's same neutron to proton ratio, yeah. So they are asking which one has the same neutron to proton ratio as helium. Yeah, helium is 2, okay, and then you can see the number of proton for helium is 2, neutron is 4 minus 2, so it's going to be 2. So neutron to proton is 2 to 2, it means 1 to 1. Yeah, the ratio is 1 to 1. So what we need to do over here is we need to find out, okay, which one, okay, will give you the ratio of 1 to 1. Yeah, so that is very, very important now. That is what we need to do now. So which isotope has the same neutron to proton ratio? So barium, okay, is 4. You just look at the periodic table, all this, yeah, 20, this is 18. All this you can get it from the periodic table. So proton wise, this is 4, proton is 3, proton is 20, proton is 18. Neutron, you find the difference 0, neutron is going to be 4, you find the difference 20, neutron is going to be 22. Okay, so we are looking for same number of proton and neutron, yeah, according to here. So not the same cannot be the answer, not the same cannot be the answer, same, that's our answer, not the same cannot be the answer. So that's why the answer is going to be C. Okay, next question, number 4. Okay, dimethyl sulfide, okay, is produced by plankton in ocean. It's oxidized by oxygen, yeah, so it's actually given to you, and then they say it's going to produce carbon dioxide, water, and sulfuric acid only. So if I write down the equation, CH3 2S, okay, plus oxygen to give you carbon dioxide, water, and sulfuric acid. You just need to write down this and then balance the equation. So there's 2 carbon here, so of course I need to put 2 over here. And then hydrogen, I have 6, okay, so sulfur is 1, I do not disturb this hydrogen, so I need 6, so I just need to put 2 here. So I'll have a total of 6 hydrogen, and then oxygen I balance towards the end. On the right hand side, I have 4 oxygen, 2, so 6, another 4 is going to be 10. So how do I get 10? I just put 5 over there. So now it's actually balanced. So the next thing that I need to do is they say how many gaseous molecules. Yeah, gaseous molecule, this is the only gaseous molecules that is going to be produced. Okay, because carbon dioxide, water is liquid, sulfuric acid is aqueous. So you use, they say 2 moles. Okay, if you use 2 moles, you look at the ratio. Yeah, so 1, 5. Okay, 2, 2, 1. Okay, so if you cannot see, I'll just bring it over here down a bit. Okay, So if you are using 2 moles, okay, if you are using 2 moles, okay, so the gases is 2, 1 to 2. So this one will become 4, okay, 2 to 4, okay, if you follow the ratio. So the answer is going to be C. Okay, Jonathan, Kevin, can you understand all this? Alright, okay, let's continue. Now, why ionic radius of bromide ion, okay, is larger than ionic radius, okay, of calcium ion, okay. So let's look at bromide ion and calcium ion, yeah. So in this case, you definitely need to look at your periodic table. So let's look at calcium, okay. So let's actually erase this. So if you look at calcium is here, okay, bromine is here. Better look at it in terms of shorthand rule. So you see argon, okay, calcium alone, okay, is going to be argon, okay, then 2s, 3s, 4s, so 4s2, yeah. And then if you look at Br, okay, Br is also argon, okay, then 4s2, then here is 3d10. And then this is 4p1, 2, 3, 4, 5. Okay, 4p5. Okay, so I'll just bring it closer here. Now, if I have calcium 2 plus, okay, calcium 2 plus, what happens? The 2 electrons is gone. So you are going to get argon. Okay. If I have Br minus, I'm going to gain electron. So 1 electron will go here. It means that, okay, I am going to get argon, 4s2, 3d10, and 4p6, which is this structure Br minus is the same as krypton. Okay, so what you notice over here is, okay, calcium, okay, calcium ion, they are argon, and then Br minus is krypton. So it means from here to here, it means you can see that there is increase in a shell, yeah, because you see this is period number, let's say this is period 2, period 3, period 4. When you have increase in period, it means the number of shells are increasing. So basically using that, okay, we will try to answer this question over here, which is going to be, they say that why ionic radius of bromide ion, Br minus, is going to be krypton. Okay, calcium is going to be Ca2 plus is going to be argon. So why it is going to be larger? Okay, to answer that question, quite simple. Okay, the answer is going to be because, okay, a bromide ion, okay, has 1 more occupied electron shell, because 1 shell extra, yeah, than calcium ion. So that's going to be the answer. Okay, the rest will not be the answer. Okay, it's not suitable to explain, yeah. Just by saying calcium is a cation, bromide is an ion, no, it doesn't explain the why bromide ion is larger, yeah. So next question, okay, for element lithium, which part of ionization energy has the largest difference between them? Lithium is going to be 3, okay, so 1s2, 2s1. So do remember, okay, if you want to find the largest difference, it means the one that is going to be before removing and the one after removing in the inner shell. Like for example, if you want to remove this 1 electron, it's quite easy to remove because they are further away, yeah, from the nucleus. So it means this is your first ionization energy. But to remove 1 more electron, the second electron, okay, is in the inner shell. Okay, so they are closer to the nucleus. So the second ionization energy is not going to be the same for all, but in this case, the second ionization energy is going to be greater because the electron is going to be removed in the inner shell, yeah, closer to the nucleus. So the gap, okay, the one that will give you the largest difference is going to be between first and second ionization energy for lithium. Yeah, please take note. Now, number 7. Which species contains the highest number of electrons? Okay, to answer this, yeah, you need to know what is going to be for hydrogen. Hydrogen is 1, okay, lithium is 3, helium is 2, beryllium is 4. You can look at your periodic table for this, yeah. So now, if it is just without the ion, okay, I know the electron, okay, without the ion is going to be 1, same as the number in the red, yeah. So electron, lithium is going to be 3, okay, helium is going to be electron 2, beryllium is going to be electron 4. But now because we are dealing with the ions, okay, you can see negative, so it means there is going to be you are going to gain 1 electron, so the electron is going to be 1 plus 1, so it's going to be 2. Here they are losing 1 electron, so 3 minus 1, so 2. Here they are gaining 1 electron, 2 plus 1, so 3. Here they are losing 2 electrons, so therefore they are going to be 2. So they want highest number of electrons. The answer is going to be C because 3. Yeah? The rest are all 2. The next question, okay, which mass of potassium nitrate, KNO3, okay, contains the same mass of nitrogen as 60 grams of urea? Okay, so in order to solve this, yeah, it's better for you to change it to number of moles to look at it more clearly. So if you calculate, yeah, so this is 12, okay, plus oxygen is 16, okay, then nitrogen is 14 times 2, so hydrogen is 1 times 2, 2 times 2 is 4. So if you add all this, okay, you will get, okay, 60. Okay, the MR of urea is 60. So number of moles, okay, number of moles of urea, okay, is going to be 60 gram divided by 60. Number of moles is 1 mole. Yeah. Do remember 1 mole of urea, okay, gives you how many moles of nitrogen? 2 moles of nitrogen. Yeah, 2 moles of nitrogen. So it means 1 mole of urea give you 2 moles of nitrogen. So what I need to do is I need to get the 2 moles of nitrogen from here. Okay, how do I get 2 moles of nitrogen over here? So I know that, okay, this KNO3, okay, they are going to be 1 mole of KNO3. It's only 1 mole of nitrogen is going to it's going to give you only 1 mole of nitrogen. Yeah, unlike for this one, they will give you 2 mole. So 1 mole will give you 1 mole. So what I need to do, I just need to find out which of the following, okay, can give me 2 moles. Yeah, so it means when I calculate this, which one gives me 2 moles? That's going to be my answer. Okay, so how to do that? Okay, potassium, okay, K is 30. Okay, you can double check. Okay, K is going to be 39.1. Okay, 39.1. So you just calculate. 39.1, nitrogen is 14, oxygen 3 times 16, which is 48. So if you calculate, you will get 101.1. This is the relative molecular mass, okay, for KNO3. So find out which one, okay, 25.3 divided by 101.1. 50.6 divided by 101.1, 101.1 divided by 101.1, this one I think 1, still not the answer, okay. This is also not the answer, less than 1, this is also not the answer. If you look over here, okay, 202.2 divided by 101.1, you will get 2. So it means that you will get 2 moles of, okay, 2 moles of KNO3, which is going to give you 2 moles of N, which is the same as here, okay, 2 moles of N. So the answer is going to be D. Okay, so that's going to be the answer for this. Okay, let's move on. Number 9. Okay, sodium hydroxide, okay, is added to hydrochloric acid, so I'll just write NaCl plus H2O, and then if you balance, yeah, you are going to get, okay, everything is balanced already, 1 more, 1 more, 1 more, and so on. So now, okay, they have all this information. What you need to do, find the number of moles first. Yeah, so 15 cm cubed, so you divide by 1000, okay, and then HCl 30, okay, times 0.15 divided by 1000. Okay, find out, okay, what is going to be the number of moles that we are talking about. Yeah, so the number of moles, okay, that we are talking about here is 1.5 times 10 negative 3. Okay, and then this one, okay, 30 times, okay, you can calculate, okay, 30 times 0.15, that's 4.5. yeah, so if I just, this is 4.5 times 10 negative 3. So we know that 1 mole will react with 1 mole. So this is extra, yeah. So if I circle, yeah, this will be used up, okay. So they are going to actually react with 1.5 times 10 negative 3 over here to produce 1.5 times 10 negative 3, 1.5 times 10 negative 3 over here. So they say how hydrochloric acid, the remaining here, the remaining is 4.5 times 10 negative 3 minus 1.5 times 10 negative 3, the one reacted. So you are going to get 3 times 10 negative 3. Yeah, this is still in number of moles. Yeah, they want concentration. So concentration is 3 times 10 negative 3 divided by volume in dm cube. But you see volume, you must include both of this volume. Yeah, so 15 plus 30 is 45. Yeah, 45 cm cube. So you need to divide by 1000. So it becomes 0.045. Okay, 0.045. Okay, when you calculate this, okay, just find out what is this value. Okay, so 0.003, okay, divided by 0.045, and you will get the answer, which is going to be 0.067. Okay, 0.067, which is this one. The answer is A. Okay, Ishana, so far, okay? Alright, okay, let's continue. Now, the most expensive cars are fitted with catalytic converter. Yeah, this one. If you read this question properly, yeah, this is all gases. Gas, 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 gas. Whenever we are dealing with gases, no need to convert it into number of moles. I already told you number of moles is directly proportional to volume. Only when it is dealing with gases, yeah, please remember that. So if you use 10 cm cube, yeah, so we can assume 10 is like number of moles. 10 was reacted to 60, okay. And then what will be the final volume of the resultant mixture of the gases when cooled? So basically, okay, according to this, according to the ratio, 2 moles will react with 2 moles to give you 2 moles and 1 mole over here. So you see this one, okay, this is the limiting region, yeah. So it means 10 will react, okay, with how many? Not 60, yeah. So instead of reacting with 60, okay, they will react with 10, okay. So there are extra of NO, yeah. So 2, so it means to produce 10, 1, so to produce 5, okay. So the one remaining, yeah, so do remember the one remaining over here, 60 minus 10, which is 50 is remaining. So they say what will be the final volume of the resultant mixture of gases. Of course, after reacting, there's nothing, okay, CO is nothing. So left with this 10, left with this 5. So what you need to do, you just need to add, okay, 50 plus 10 plus 5, okay, you will get total 65. Okay, so the answer is A. Now, the next question, which compound contains both covalent and ionic bond? Okay, do remember ammonium ion, you should know, yeah, this is covalent, okay, then H plus, okay. So this is coordinate bonding, yeah, to give you NH4 plus. So coordinate bonding is a type of covalent bonding. Okay, so you are not going to actually consider it as covalent and ionic. So this is automatically wrong. KF, okay, K is K plus, F is negative, okay, metal and non-metal. So of course this is 100% ionic, nothing to do with covalent. Now potassium cyanide, K plus Cn minus. Hydrogen cyanide, HCN. Now be careful with this because students will always say H plus and Cn minus. No, not really. This one is similar to HCl, yeah. Okay, HCl, okay, is a covalent molecule actually. Yeah, so HCN also is a covalent molecule. Why? H, okay, they share the electron with the carbon, okay, and then they will share the electron over here with the nitrogen. So you will have this. Yeah, this is going to be the cross and dot diagram for HCN. So they are perfectly covalent, nothing ionic about them. Yeah, but for KCN, yeah, KCN itself, KCN itself is a covalent. Yeah, CN itself, the ion, is a covalent bonding between carbon and nitrogen, non-metal and non-metal. K plus and Cn minus, they will give you the ionic. Okay, so therefore the answer is going to be B, not A. Yeah? Please remember that. Now, next question. Which row is correct? Now, whenever we are dealing with nitrogen, remember, yeah, it's a very tricky question. Okay, you must have nitrogen will always form 3 bonds. Yeah. So if you want to erase this part, you see, if I just try to make it, okay, rather than like this, okay, I'll just I write it like this. Okay, the hydrogen, okay, I put it this way. Hydrogen like this, hydrogen like this, hydrogen like this, hydrogen like this. 3 bonds, okay, surrounding nitrogen. Group 15, 5 valence electrons, so 1, 2, 3. So the remaining 2 electrons will be over there. Same, remaining 2 electrons will be there. Okay, for carbon 4, okay, 4 hands, so 1, 2, 3, 4, so no issues. Oxygen, be careful, okay, oxygen, okay, also, okay, they have 2 electrons over here. Oxygen is group 16, so they will have another, okay, 4 electrons, okay, they will have another 4 electrons over here. Okay, so you will have group 16. Yeah, so now let's actually see how many lone pair. Okay, let's see how many lone pair. 1, 2, 3, 4. There are 4 lone pair. Okay, so 4 lone pair. How many pi bond? Pi bond. Okay, one of it will be sigma, another one will be pi. Okay, so 1 pi bond. Okay, sigma bond, let's see how many sigma. So one of it is going to be sigma, so 1. So this is sigma, this is sigma, 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 sigma. How many you count? It's going to be total. Okay, 1, 2, 3, 4, 5, 6, 7. Total 7. Yeah, so you have the answer is going to be D. Okay, so let's move on. Now, which of the molecule contains the largest bond angle? Okay, just by looking at this, you should know this is tetrahedral 109.5. Okay, memorize, yeah. Okay, this one, phosphorus, if you look at your periodic table, this is going to be group 15. Yeah, so it means similar 5 valence electron, 3 used for bonding, so they have, okay, 1 lone pair and then 3 hydrogen over there. So this is similar to ammonia. Ammonia will have pyramidal structure. So this is going to be 107 degrees. Yeah, 107 degrees. Okay, and then, okay, if you look at C3H8, then like this, okay, you can see that there is no double bond, but each of these carbon have 4 bonds. So if it is 4 bonds, okay, so automatically this is going to follow tetrahedral 109.5. So let's look at the last one. Okay, sulfur dioxide, they will have something like this. But do be careful, okay, if you have, okay, the electrons, okay, if you have 2 electrons here, 2 electrons here, okay, sulfur is group 16, okay, not only 4 electrons, they have another 1 lone pair of electron, okay, 6 valence electron. So if you look at it, okay, it will look as though they have, okay, I told you double bond or not, I told you count it as 1 bond, yeah. Okay, so it looks like sulfur will have 1 bond, and then like this. So what is the bond angle? Yeah, so it is similar to 3 bonding pair. Okay, because we are going to count this as bonding pair. Yeah, which is going to be supposed to be like 120 degrees. But do remember, because lone pair and the bonding pair repulsion is greater, they are going to push the bonding pair to become smaller. So it will be slightly smaller than 120. So they are not going to be exactly 120. Probably, I will say maybe 118 degrees will be best option to go. Okay, but now they are asking which one is going to be the largest bond angle. You compare. Okay, whatever it is, okay, automatically this is going to be the largest bond angle. Okay, next is going to be related to hybridization. Okay, for hybridization, okay, you just need to remember how many orbitals, okay, that are required for bonding. You see, yeah, 1, 2, 3, 4. You require 4 orbitals. So you use sp3, 1s and 3p orbital. Total 4 orbitals. Okay, this one, if you memorize like what I taught you, okay, you will be able to answer this quickly. Yeah. So you have a look at the 2 asterisk over here. 1, 2. I told you if you have double bond and triple bond, you only count 1. You choose this one only. Yeah. So there are 3. Okay, if you have 3, so we are looking for 3 orbitals. We are not going to look for sp3. We are going to look for sp2. 1s and 2p. So total 3 orbitals. So that's going to be sp2. Yeah, so sp2. And then let's look at oxygen. Now oxygen need to be very careful. Yeah, oxygen, I told you, okay, double bond, okay, choose only 1. I'll use the red color. Yeah, choose only 1. Okay, and then okay, oxygen. Okay, you have 2 electrons already for bonding, but oxygen is group 16. Okay, I told you they have 6 valence electrons, so the remaining 4 electrons will be there, not shown. Okay, lone pair. Treat the lone pair as 1 orbital also. 1 orbital, another orbital. So total how many orbitals that we are dealing with? Okay, we are dealing with total of 1, 2, 3 orbitals. Okay, ignore the pi bond. Yeah, so we are dealing with 3 orbitals. So what kind of hybridization we are talking about? sp2 again. Okay, 1s and 2p. So 1s, okay, maybe for this, and then the remaining 2 sp orbitals, okay, will be for these 2. Yeah, so do remember how I taught you on this. Yeah, so this one will be sp2. So the answer is going to be C for this. Now, let's continue. 15. Okay, which type of intermolecular forces can exist, okay, between adjacent butanamide molecules shown in the ascending order? Okay, the weakest first. Okay, so if you look at the weakest first over here, so weakest, of course, is going to be instantaneous dipole, induced dipole. Don't go and see all this. Okay, of course, no. So, and then do remember this is going to be, there's oxygen, there's nitrogen, there's delta plus, delta negative. Of course, they will have PD. Okay, and then there will be hydrogen bonding, no doubt in that. Because why? There is delta negative oxygen, delta negative and nitrogen, delta positive hydrogen. In a molecule, if you have delta negative nitrogen, delta positive hydrogen, yeah, that's an indication where, okay, they can have hydrogen bonding. So please take note. Yeah, so this one, okay, the answer is A. Okay, done. Okay, they say weakest first. Yeah, so I already done. Now, which of the following solid have a simple molecular lattice structure? Zinc. Zinc is metal. Yeah, metal is metallic bonding. Giant metallic structure. Cannot. Silicon peroxide, SiO2. I told you diamond and SiO2. They have, okay, graphite, diamond, SiO2. They are giant covalent structure. Giant covalent lattice. So they will not come into this. Yeah, do remember I told you each Si, okay, is bonded to 4 oxygen atom, and 1 oxygen atom is bonded to 2 Si atom. I told you to memorize this. Yeah, please remember. Okay, so anyways, aluminium oxide is going to be, again, is going to be ionic compound. Do remember, ionic compound is all ionic compounds, they are giant ionic lattice. Yeah, giant ionic lattice. So of course they are not going to be having simple molecular lattice. Phosphorus, on the other hand, is P4, similar with sulfur, S8. All these are going to be 4 atoms of phosphorus, so they are simple molecular lattice. Okay, so the answer is going to be C. 17. Now, when a sample of ammonia gas is compressed at constant temperature, okay, when you decrease the pressure, okay, when you increase the pressure, the volume is decreasing. Of course, understandable. Yeah, you increase the pressure, volume will actually become smaller. Okay, which is possible explanation for this result? Okay, liquefies, no. Yeah, just because you decrease, you cannot just say from these values it's going to totally become liquid, no. Okay, this one we wait first. Okay, intermolecular forces between ammonia get stronger. Do remember, okay, when you try to actually increase the pressure, volume changes. Nothing to do with the intermolecular forces. Maybe, okay, it will become more prominent, yeah, but doesn't mean that they become stronger. Yeah, they become, you cannot ignore them. Yeah, you cannot ignore them. Okay, so this one might not be a good answer, okay, to select, but let's wait first. Some of the ammonia gas is escaped from the container. Definitely no. Okay, we don't, they are going to compress. Okay, definitely it's got nothing to do with suddenly the volume is decreasing, ammonia gas escape from the container. No, you can cancel out A and D. Now for this question, okay, the best answer or best way to answer this is you use PV equals to nRT. Okay, and we know that PV, okay, divided by RT equals to N. Okay, R is going to be a gas constant. Temperature, they say constant. You can just simplify this as number of moles is directly proportional to pressure times volume. Okay, and do remember, okay, in this case when we are compressing, it means we are dealing with the same number of moles of the molecule. Yeah, so if let's say if I have N1 and then the N2, it must be the same as well. Okay, so what we can do is, maybe I just write down N1 directly proportional with what? So I just put, I don't change the unit, yeah, I just use the existing unit. So 4000, okay, times volume. Volume is 85 earlier. Then N2, okay, is going to be 7500. Okay, then the volume becomes 35.4. Now, what I can do is, okay, if I have N1, okay, this equation divided by this equation, okay, N1 divided by N2, okay, must be equals to 4000 times 85 divided by 7500 times 35.4. Now, we need to prove that N1 is the same as N2, because if it is ideal, must be the same. Yeah, must be the same. It means that this value, the same value divided by the same value, we supposed to get 1. Let's see whether we are getting 1. Okay, if they are ideal, they must give you 1. Okay, so we calculate. Okay, so this one, the best way to show, yeah, is just by calculating. So you just calculate 4000 times 85, okay, divided by 7500 times 35.4. And okay, when you calculate, okay, you are not going to get 1.28. Okay, so you are getting 1.28, which is not 1. If it is not 1, okay, it means that they do not behave ideally. If they are ideal, they must be 1. Okay, so this is going to be how you reach to that answer. Yeah. So question number 18. Okay, at a temperature of 5000, okay, pressure is given. A sample, okay, has a volume and so on. What is the formula? So we can use PV equals to nRT. Okay, pressure, okay, is going to be 2.5 times 10 negative 4. Volume, okay, you must change it to meter cube, yeah. So 3.05 times 10 to the power of 8. D is 10 negative 1. 10 negative 1 to the power of 3, yeah. 10 negative 1, 10 negative 1, 10 negative 1, meter. Okay, deci is 10 negative 1. So it means in total it will become 10 negative 3 meter cube. Yeah, we want to change it into meter cube. Okay, number of moles. Okay, so number of moles, okay, you are going to use 0.490 divided by mR. Okay, and then R is 8.31, gas constant. Okay, temperature 5000 Kelvin, so I just put 5000 Kelvin. So find out what is mR. Okay, you find out what is mR. Okay, you calculate. Okay, while I write this, you can also calculate. Divided by 2.5 times 3.05 times 10 to the power of 4, 10. Okay, so I just try to calculate also. 0.49 times 8.31 times 5,000, and then divide by 2.5 times 3.05 times 10, close the bracket. 267, yeah. So the MR is 267. So I need to calculate which one will give me 267, yeah. Okay, so you need to calculate, okay, 267. But okay, if you want to do it faster, okay, PB, okay, if you look at PB in your periodic table, okay, PB is going to be 207.2. So what I can do, I find the difference here. Okay, I find the difference. 267 minus 207.2. Anything that can give me, okay, 59.8, okay, will be the answer. So what I mean is, okay, this, okay, anything that can give me this value will be my answer. So oxygen 2, so it's 16 times 2, yeah, so that's going to be 32, okay, cannot be the answer. Okay, CO3, so 12 plus 48, that's going to be 60, yeah, close to 59.8, this might be the answer. Okay, Cl2, 35.5, 71, yeah, so cannot. Okay, C4, okay, 4 times 12, 48, yeah, cannot be 59.8, so my answer is confirm B. Okay, so figure out how you can actually get the answer, yeah. Now 19, yeah, this one Buckminster fullerene we have learned, yeah, C60, yeah. So each carbon, okay, is bonded to 3 other carbon atoms, okay. Because of that, okay, there is going to be 1 electron that is going to be existing at every 1 atom of carbon. So it means that, okay, the reason for the reactivity, we are looking at electron. So the reason for the reactivity over here is we are talking about high electron density, yeah. So this is going to be the answer. The others are not going to be suitable. Okay, now 20. They say that, okay, you dissolve with sodium hydroxide in distilled water is an exothermic reaction. What is the correct observation? Exothermic, it's going to become hot, yeah. So temperature decrease, no, yeah, no. So temperature is increased. So the answer is going to be D. And this is quite easy. 21. Now zinc oxide, okay. If you have zinc oxide, okay, it's a basic oxide, can be obtained by all this. So using Hess's law, which of the 3 values that are needed to calculate enthalpy change for this reaction? Now this one, okay, if there are many ways to calculate, okay, one of the easiest way is to just the one that I told you. If you know the formation, okay, formation of oxygen, no need because it's 0, yeah, because element. So if you know the formation, definitely you can calculate what is this, yeah. So here you see the first example, yeah, formation, you know, they give you this formation, they give you this formation, they didn't give you the formation of oxygen, doesn't matter, okay, you can straight away calculate. The other answers doesn't make sense. You are not going to be certain whether you are going to able to calculate or not. No need to think so much. Combustion, don't worry so much. As long as you have all these formation values, I'm certain I can calculate. So just use this A as an option, yeah. Now number 22, displacement is a exothermic reaction, yeah. So if you have magnesium, okay, magnesium powder is added to copper sulfate, yeah, copper sulfate solution. So what you are going to get? You are going to get magnesium sulfate plus copper, okay. And then you can see, okay, what is going to be the amount, number of moles that is going to be used up. Yeah, so the number of moles that is going to be used up over here is 50 times 0.01 divided by 1000. You can calculate the number of moles. Okay, so once you have this number of moles, okay, you just calculate how many moles over there. Okay, that's going to be 5 times 10 negative 3. Yeah, that's going to be the number of moles. So you know 1 mole, 1 mole, 1 mole, 1 mole. Yeah. So if you have, okay, in this case the temperature is rising, it's an exothermic reaction. So you can write Q equals to mc delta T. Okay, the mass, we are going to find the increase of the temperature of the water. Yeah, the mass is going to be 50 cm cube. 1 cm cube is 1 gram. So 50 gram. Okay, the C is 4.18. It's provided in the question. Yeah, at the back you can see. And then delta T is going to be 4. Yeah, 25 to become 29. Yeah, no need to change it to Kelvin. Yeah, so once you calculate that, you will get the answer in joule. Yeah, let's actually calculate that. Okay, 50 times 4.18 times 4, 836. Okay, so this is 836 joule, and that is for how many moles? This amount of moles. I'm looking for 1 mole. Yeah, so how do you get for 1 mole? Okay, because enthalpy change is for 1 mole. Yeah, so 836 you divide by, okay, 0.005. Yeah, so you will get, okay, 167,200. Okay, which is going to be in joule. Okay, in joule. So what? Okay, 167,200. Just double check. Yeah, 54.18. Okay, times 4, 836. Okay, then you divide by 0.01. 10 negative 2, 0.5. Sorry, yeah. So there is a mistake here. Negative 4. Yeah. 10 negative 4. Okay, so you divide by, okay, you just divide by 836 divided by 0.0005. Okay, that's going to be 1672000. Okay, so you divide, okay, you change it to kilojoule, you get 1672. But don't go straight away answer, yeah, because it's going to be exothermic. It must be negative. Yeah, please take note of that. Okay, the next question, okay, it's involving decomposition. Okay, for the decomposition, okay, so they want to find the enthalpy change. So SF6 is going to give you SF2 and then F2. So you balance, you just put 2 there. Okay, and then, okay, this is bond breaking and bond formation. So bond breaking, how many? Okay, you can calculate 6 times SF. Okay, 284. Bond forming, okay, 2 times 284, and then 2 times, okay, 155. You add first. Okay, so let's actually calculate first. 6 times 284. 6 times 284, 1704. 2 times 284, 568. Okay, then you add with 2 times 155, 87. Okay, 878. So do remember, bond forming is negative here. Yeah? Just put negative. So you add these two. Okay, so 1704 minus 878. Okay, that's going to be the answer. 826 plus 826. Okay, so this answer is plus 826. Now, the next question, okay, they are going to actually tell, yeah, At high temperature, limestone can decompose, yeah, so pathway. So it's an endothermic reaction, yeah. So this is exothermic, must be endothermic, must be endothermic, must be endothermic. So let's look at activation energy. Activation energy must be from reactant to the top, yeah. So this is going to be the answer, yeah. Now, next, okay, 25, okay, they say what is the oxidation number? Now, if you follow whatever that I say, yeah, potassium manganate 7, yeah. So if you remember or memorize, this one quite easy, okay. This one, okay, sulfur, okay, X plus 2 times negative 2 equals to 0, X minus 4 equals to 0, X equals to 4. Okay, sulfur is going to be 4. So if you know that, I think no need to calculate the others, the answer is going to be C, yeah. Now, the next, okay, lead is reacting with concentrated sulfuric acid to give you PbSO4 and hydrogen gas. Okay, I didn't balance it, but it's okay, doesn't matter. From 0, so this one SO4 2 minus, so this one must be Pb plus 4, yeah. You can calculate on your own, yeah, but again what I can see is they are going to be from 0 to become plus 4, yeah. So they are oxidized, so definitely they are oxidized. How many electrons are lost? Okay, in this case they lost 4 electrons, so the answer is going to be C, yeah. Next, okay, this is disproportionation reaction. So what is disproportionation reaction? The same element it can be oxidized and also can be reduced. So the best answer, this one not the answer, yeah. So they are going to be, some will be oxidized, some will be reduced. Okay, next. Now, what is going to be a reducing agent? Reducing agent is going to be something that will reduce others, but they themselves will get oxidized. You can go through all this, yeah, but if you look at this magnesium or 0, okay, this one is going to be CH3COO minus, so that's 2, so this one is going to be plus 2 if you calculate. Okay, so there is going to be increase in oxidation number for magnesium. Okay, so therefore reducing agent means something that will reduce others, but they will get oxidized. So the answer is going to be D. Yeah. The rest you can just double check. Maybe I'll just show you this one. Yeah. So for hydrogen is plus 1. Hydrogen over here is 0. So you see they are going to be in this case reduced. Yeah. So A cannot be the answer. Yeah, and so on. You can eliminate them. Now for 29. Yeah. This one I have taught you last time. Yeah. Copper. Okay. This is 0. This is plus 2. So you just put from here plus 2. Okay, this one is 1 and 1, so from here to here, okay, x minus 6 equals to negative 1, so x equals to plus 5, so from plus 5 to become plus 2 over here, yeah, so that's going to be minus 3. So what we need to do, we find the exact ratio, times by 2, okay, times by 3. So if you put 3 over here, okay, 3 will be put over here. If you put 2 there, you put 2 there, and then you must put 2 there, okay. And then next is, if you put 2 there, oxygen will become 6. So you have 2 here, so how to make it 6? You just have to put 4 here, and then hydrogen will become 8, so I need to put 8 over here. So in the end, okay, you will have 8, Q is going to be 4, okay, Y is going to be 2, X is going to be 4, so D, yeah. So the rest, okay, you see here, which factor will affect the value of Kp? Only temperature, okay, will be affected. So the answer is going to be A. Okay, just give me a few minutes, yeah. Now, what is the value of Kc? Okay, Kc is going to be concentration of Z, okay, W to the power of 2 divided by Y to the power of 2 X. So if I have Kz over here, Z is going to be 1. W is going to be 2 to the power of 2, Y is going to be 2 to the power of 2, X is going to be 4. So if I calculate, yeah, you can cancel the 2 to the power of 2, 2 to the power of 2, you get 1 over 4. So that's going to be my answer, C. Now 32, okay, which species acts as Bronsted-Lawrence base? Bronsted-Lawrence base is going to be a proton acceptor. Okay, so proton acceptor means, okay, they are going to be having a lone pair to donate, and this is the only molecule that can actually donate lone pair, because they have 2 lone pair, okay, surrounding the oxygen. So that's going to be the answer, B. The rest of them, they don't have any lone pair to be donated, so they cannot become the Bronsted-Lawrence base. Okay, and then 33. Okay, if you look at 12, okay, quite difficult because normally strong base will be 13. Yeah, I taught you. So if you, a best way to look at it is 10.5 over here until somewhere 7.5. So it's more inclined towards strong base. Yeah, so we are dealing with strong base. And if you look over here, this is going to be pH around 4 or 5. So that's going to be a weak acid. So let's actually look at, it's supposed to be a strong base, and then weak acid. So the answer is D. Yeah, and the last one, yeah. So Kc is going to be SO3 to the power of 2 divided by SO2 to the power of 2, then O2. So the value over here is greater than 1. If it is greater than 1, this value must be greater than this. So of course this one must be greater than this at all times. So the answer is going to be D. Yeah. With that, yeah, we have completed, yeah, this paper. Yeah. Thank you guys.